Last class we discussed about the equation of tangent to the parabola at a point x1, y1. What we discussed? This is a parabola. To this parabola, y square is equals to 4ax at a point x1, y1. At a point x1, y1, let us say that point is also p x1, y1. A tangent is drawn. This is the tangent drawn. The equation of this tangent is given by s1 is equals to 0. That's what y1 minus 2a into x plus x1 is equals to 0. Now can anyone say what is the slope of this line? This line slope is equals to minus of x coefficient divided by y coefficient, that is nothing but 2a by y1. Yes, this tangent slope we got 2a by y1. Okay, leave it there. Now my discussion is, what is the geometrical meaning of differentiation at a point x1, y1? Differentiate this curve at a point x1, y1, what we will get? We are differentiating this curve at a point x1, y1, what we are going to get? Okay, differentiate it. Y square differentiation is 2y into y differentiation dy by dx is equals to 4a into x differentiation 1. Now I can write dy by dx is equals to, no doubt we are getting 2a by y. Next what I am doing, differentiating the given curve at a point px1, y1. That means wherever x is there in place of x we have to write x1, wherever y is there in place of y we have to write y1. Then what we will get? 2a by y1. Here also we got 2a by y1. What is 2a by y1? 2a by y1 is nothing but tangent slope. Tangent slope. Differentiation of the given curve at a point px1, y1. We are getting slope of this line. This line is nothing but tangent. That means any curve differentiate at a point, then what we will get? At that point we are drawing a tangent. That tangent slope is given by differentiation at a point, right? So this is the curve given. On this curve at a point px1, y1, a line is drawn. To get this line slope, what we can do? Differentiate this curve at the point x1, y1. Differentiated the curve at a point x1, y1, we got slope of the tangent. That is geometrical interpretation of differentiation at a point. So differentiation of the curve at a point x1, y1, we will get slope of the line. Where we are drawing this line is a tangent to this curve at a point px1, y1, right? Differentiation at a point p is nothing but slope of the tangent. So that is the information. So now point is there x1, y1, slope is there. So we can find out the line equation. Y minus y1 is equals to 2a by y1 into x minus x1. So with this simplification, no doubt you will get this line s1 is equal to 0. Just I want to introduce an idea of slope of the tangent is nothing but differentiation of the curve at a point. Okay, right. So now I am going to introduce another idea. What is an increasing function? What is a decreasing function? So this increasing function and decreasing function in detail we are going to discuss in +2 syllabus, but at present I want to introduce these ideas a little bit basic level so that we can discuss some higher level problems also. Okay. Observe here. If you observe the graph, by observing the graph, what we can say? The graph of this function. Let us say this function is y is equal to f of x. If you observe the graph, what happens? Increasing. That means observe, as x values are increasing, the graph also increasing. Yes, you can observe another one here. This is the graph of a certain function. What happens here also? Here also same thing happens. When x values are increasing, the graphical values also increasing. So this is an increasing function, right? Observe here. I am taking a point here as x1 comma 0, a point on x-axis, and here I am taking another point as x2 comma 0 is also a point on x-axis. Now this is a line, and here also another line I am drawing. Can anyone say what about this point? No doubt this point x coordinate is x1 only. This point is on this curve. In place of x, if you write x1, the y coordinate becomes f of x1, right? Next, here x2, that's why here also x coordinate is x2 only. If you put x is equal to x2, then what is y? You will get y is equals to f of x2. So what happens? This point is x1 comma f of x1, and this point is x2 comma f of x2. Now clearly you can observe x1 is less than x2 or not? No doubt x1 is less than x2. Now this height is more or this height is more? No doubt this height is more. That's why I can say f of x1 is less than f of x2. Array x1 less than x2 implies f of x1 is also less than f of x2. Then the function is said to be a strictly increasing function. x1 less than x2 implies f of x1 is also less than f of x2. Then this function f is said to be a strictly increasing function, right? That is one way. Now observe here, to this curve at any point, not only at this point, any point you can draw a tangent. Okay, tangent is drawn. This is the tangent drawn, right? Let us say this angle is equals to theta. If theta is the inclination of this line, then what we will call tan theta as slope. Tan theta is the slope, but as we discussed, slope with the help of the differentiation is nothing but f dash, right? So at a point a tangent is drawn. The tangent slope is nothing but differentiation. F dash means dash denotes differentiation only. So f dash. Now tell me, theta is no doubt an acute angle. Theta is an acute angle means tan theta is greater than 0. Tan theta is nothing but differentiation, that is f dash of x. Array f dash of x greater than 0. Not only at this point, you can draw a tangent at this point. You can draw a tangent at this point. Anywhere you can draw a tangent. That tangent makes an angle theta. That theta is an acute angle. Theta is an acute angle means tan theta is positive. Tan theta is nothing but f dash of x is positive. And f dash of x greater than 0, then the function is said to be a strictly increasing function. This is one idea. x1 less than x2 implies f of x1 less than f of x2, then the function is said to be strictly increasing function. F dash of x greater than 0, then also the function is said to be a strictly increasing function, right? The same way we can discuss about a decreasing function also. You can observe here, this is the graph of one particular function. This is the graph. The same we can draw in another way also. this is the graph of a function. So this function is equal to, say, y is equals to f of x. Y is equals to f of x. Now here there is a point x1 comma 0, and here we have a point x2 comma 0. No doubt, just like as the earlier discussion, this corresponding point on the curve is nothing but x1 comma f of x1, and this point on the curve, this point is nothing but x2 comma f of x2. No doubt, whenever x1 is clearly less than x2, right, implies, can you tell me what is f of x1 and what is f of x2? Observe f of x1. F of x1 is nothing but this height. F of x2 is nothing but this height. No doubt, f of x1 is greater than f of x2 or not? x1 less than x2 implies f of x1 greater than f of x2. x1 less than x2 implies f of x1 greater than f of x2. Inequality changes. This function is said to be a strictly decreasing function. You can observe, as x values are increasing, the functional values are decreasing. So it is a strictly decreasing function. Whereas here, the another way, anywhere you can draw a tangent. Okay, tangent drawn at a point. This is the tangent drawn. That tangent with x-axis makes an angle theta. Tell me that theta is an acute angle or obtuse angle? Theta is an obtuse angle. That means tan theta, no doubt, less than 0. Tan theta is nothing but slope of the tangent. Slope of the tangent is nothing but f dash of x. Right? F dash of x is equals to tan theta, that is less than 0. So f dash of x less than 0, then the function is said to be a strictly decreasing function, right? So x1 less than x2 implies f of x1 greater than f of x2, then the function is said to be a strictly decreasing function. Or f dash of x less than 0, then the function is said to be a decreasing function. Increasing function, strictly increasing function means f dash of x greater than 0. Strictly decreasing function means we got f dash of x less than 0. Okay, so bye bye.